Okay, we're going to pick up where we left off. And this time we're going to use Sum and Difference Identities to find the exact value of an angle in radians. So we're trying to find the exact value of sine pi over 12. All right, in this case, you got to consider several things. In order to answer this question, you need to find two of the angles that we know to either add together, subtract from each other, that will give us the angle pi over 12, just like we did in degrees. Let's start by looking at the angles that we actually know. First one we know is pi over 6. Now the angles that I'm starting with are those that come from the unit circle, all in radians. So we're not dealing with degrees. So instead of 30, 45, 60, and multiples thereafter, we're looking at all of those angles in radians. First one we know is pi over 6. Because the denominator here is 12, we're converting it to an equivalent fraction with a denominator of 12. Because 6 times 2 is 12, pi times 2, 2 pi. Next one we know is pi over 4. 4 goes into 12 3 times, so 3 times pi, 3 pi. Next one is pi over 3. Pi over 3, 3 times 4 is 12. Pi times 4, 4 pi, sorry. Next one we know is pi over 2. Well, 2 goes into 12 6 times. 6 times pi, 6 pi. As we continue around the unit circle worksheet, or just the unit circle for that matter. Next is 2 pi over 3. Well, 3 goes into 12 4 times. 4 times 2 pi, 8 pi. I can continue. Next one, 3 pi over 4. 4 goes into 12 3 times. 3 times 3 pi, 9 pi. Next, 5 pi over 6. 6 goes into 12 2 times. 2 times 5, 10. And again, the whole reason why we're doing this is if I'm trying to find two numbers that either add or subtract to give me something over 12, I'd like to use numbers that already have a denominator of 12. Next is pi. Pi is the same thing as 1 over 1 or 1 pi over 1. 12 pi or 12 reduces to pi. So if we continue this, again, same problem, using this to find sine of pi over 12. Well, from all of those, we have several choices of angles that we can subtract from each other to get pi over 12. We will pick the smallest two such angles. So the first two that we actually came up with, pi over 6 is 2 pi over 12, and pi over 4, 3 pi over 12. If we subtract these two, since now we use the difference formula for the sine function to calculate the exact value. So again, the original problem was sine. We saw that if we subtract the 2 pi and the 3 pi, that will give us pi. So we're using sine and subtraction. So there's the formula that we're using. Just to illustrate that I could have used several different values, I have a resource here. So I've taken all of the degrees and the original radians. I converted each of the radians into equivalent fractions with a denominator of 12. So if I chose these two, 8 pi over 12 and 9 pi over 12, 9 pi minus that 8 pi will give us the 1 pi, the 1 pi over 12. Or I could have used these two. No matter what two I would have chosen, I still actually in the end will have the exact same answer. So I've just chosen the two smallest values, the 2 pi over 12 and the 3 pi over 12. So here we go. So again, we're using the formula, the identity, the difference identity for sine. Again, because Sinbad is in charge, Sinbad sits next to cosec. So in this particular case, my A is going to be pi over 4. Pi over 4 came from the 3 pi over 2 that I reduced. And B will be pi over 6, which comes from the 2 pi over 12, which was also reduced. So the original problem that was sine of pi over 12 will now be rewritten as sine of 3 pi over 12 minus 2 pi over 12. Or I could simplify that to the pi over 4 and the pi over 6. So the 3 pi over 12 is the pi over 4. Now 2 pi over 12 is the pi over 6. Substituting these values, these a's and these b's, into the formula gives us the sine pi over 4, cosine pi over 6, etc. So that means I need to substitute values for sine pi over 4, cosine pi over 6, etc. So I'm going to go to my resource and determine I need the sine and cosine of these two values. So there's the pi over 4, pi over 6. Pi over 4 is like our 45 degrees. Everything before was radical 2's over 2's. Sine of pi over 6, 1/2. Cosine pi over 6, radical 3 over 2. So these are the numbers we'll be substituting. So there we go. Sine of pi over 4, radical 2 over 2. Cosine pi over 6, radical 3 over 2. I'm sorry, sine of pi over 4 is radical 2 over 2. Sine of pi over 6, 1/2. Cosine pi over 4, radical 2 over 2. So all I got to do is now simplify. Radical 2 times radical 3, radical 6. 1 times radical 2 is our radical 2. So there's our answer. Again, the denominator is the same. Final answer, radical 6 minus radical 2. All over 4. Look at another situation. Cosine negative 19 pi over 12. So just like in the previous problems where we had degrees and we're using the strategy of 45 degrees. Well, 45 degrees is the same thing as 3 pi over 12. So this will kind of sort of be the base we use. We want to manipulate 3 pi over 12. So if we see here, I could use my negative 19 pi. So we'll do the same thing we did before with degrees. I can take 19 and add 3. So that means 3 minus the 22 is the negative 19. So we're going to be using 3 pi over 12 and 22 pi over 12. There we go. So these will be the values we'll actually substitute into the difference formula. So there's the difference formula for cosine. Because coset's in charge, there's the two, cosine and cosine together. So our A here will be the pi over 4 again. 3 pi over 12 reduces. And the 22 pi over 12 reduces to the 11 pi over 6. So again, you could either choose the pi over 4 and the 11 pi over 6, or you can choose the 3 pi over 12, the 22 pi over 12. You'll get the exact same answers. So our new problem, instead of cosine negative 19 pi over 12, it's now 3 pi over 12 minus 22 pi over 12. Or the simplified version, pi over 4, which came from the 3 pi over 12, or the 11 pi over 6, which came from the 22 pi over 12. So you can choose to use the green values or the purple values. You'll get the exact same answer. So when we substitute it into the formula, I'm using the smaller values. There's my two cosines, pi over 4 and 11 pi over 6. Pi over 4, 11 pi over 6. So those are the values I need to determine. The sine and cosines for pi over 4 and 11 pi over 6. Well, the pi over 4, again, was the radical 2's over 2. And the 11 pi over 6 down here, well, negative 1/2 radical 3 over 2. So let's substitute those numbers in. There's the pi over 4, which is radical 2 over 2. 11 pi over 6, radical 3 over 2. So it's just a matter of just keeping track of where the numbers will go. Let's simplify. Radical 2 times radical 3, radical 6. And radical 2 times negative 1, negative radical 2. There we go. There's our answer. So when we simplify this, we have the exact same denominator as our radical 6 minus radical 2 all over 4. So now we'll look at sum and difference for tangent. The sum and difference for sine and cosine had its particular formula. Now tangent has its own formula. The formula is tangent, or the identity is tangent of u plus or minus v. Don't get involved about the u and the v, whether it be an a and the b, the u and the v is the same thing, any two letters, is equal to tan of u plus or minus tan of v all over 1 minus plus. So we've seen this already. Tan u, tan v. So just like the sine and cosine, this is two separate identities in one. The first one with the sum is going to be tan u plus v is equal to tan u plus tan v all over 1 minus tan u times tan v. For the difference, u minus v, tan u minus tan v, 1 plus tan u times tan v. When we start to look at it closely, we notice that, whatever the sign in the original was, that's what's on top. And inversely, whatever's on top, the opposite is on the bottom. So we'll apply one real quick. Let's see what we get. Find the exact value of tan negative 15. So again, we try to find two numbers, in this case that subtract to give us negative 15. Again, 30 and 45. I'm sorry, 45 and 60. My apologies. So 45 minus the 60 gives us the negative 15. Because again, if I had used 30, I could have used 30. I could have done 30 minus 45, and it would have given us the same negative 15. So as long as you got any two numbers that do subtract to give you the negative 15. So the new problem, instead of negative 15 for tangent, is tangent 45 minus 60. So we're using a different form of the tangent identity. Substitute these values in. So for u is going to be 45 and v is 60. When we substitute in, we got tan 45 minus tan 60. So notice the operations are the same on top, different on the bottom. So we need to go find the values for tan 45 and tan 60. Tan 45, there's 45 and 60. Tan is 1, and 60 is radical 3. So these are a little simpler because you're only using two values here. Tan 45 was the 1, tan 60 was the radical 3. Denominator 1 plus, there's the tan 45 is 1, tan 60 radical 3. If we simplify this, the denominator can be simplified just a hair. So let's go to the calculator and let it tell us what our answer is. So let's clear this. It said 1 minus the square root of 3 over 1 plus the square root of 3. And there's our answer. Radical 3 minus 2. Radical 3 minus 2. And again, we're finding these values without using the trig functions on the calculator. I'm going to finish the last one on the next video.